Okay, let's talk about a machine so incredibly powerful, it's making some of the smartest people on the planet question, well, pretty much everything. We're talking about Google's new quantum computer, the Willow chip. And look, it hasn't just broken a few records, it has absolutely obliterated them. To really wrap your head around just how big of a deal this is, let's start with a number, a really, really big number.
Yeah, take a good look at that. That's 10 septillion years. That's a 1 with 25 zeros after it. Now, get this. That's the estimated time it would take the world's fastest supercomputers, not just one, but all of them working together to solve one particularly tricky problem. It's a time frame so ridiculously huge, it's basically the same thing as saying it's impossible. And this is how long it took the Willow chip for that exact same problem. Less than 5 minutes. No, that's not a typo. We went from 10 septillion years down to the time it takes to make a cup of coffee. The gap here, it isn't just an improvement. It's a completely different reality. It's a fundamental shift in what we even thought was possible. So I know what you're thinking. How on earth is that even possible? How can one single machine do something that is, for all practical purposes, impossible for all of our other technology combined? Well, the answer pulls us into the totally bizarre, fascinating, and kind of weird world of quantum mechanics. Okay, so to really get a handle on what Willow is, you kind of have to throw out what you know about regular computers. We are not just talking about a faster chip here, we're talking about a machine that runs on rules that seem to completely defy common sense. It's almost like it's bending reality itself to get the answers. And to even try and wrap their heads around this kind of power, some scientists are using this totally mind-bending idea, the concept of parallel universes. Now hold on, this isn't proven science fiction fact or anything, but it's a powerful way to visualize what's happening. Imagine the computer is exploring all possible answers at the same time by, well, almost outsourcing the work to other realities. It's a wild thought, right? So to really get to the bottom of this magic, we need to look at what truly separates a quantum computer from, say, the phone or the laptop you're watching this on. And it all boils down to the most fundamental building block of information. See, your computer, my computer, they all use bits. Think of a bit like a simple light switch. It's either on or it's off, a 1 or a 0. That's it. But a quantum computer, it uses something called a qubit. And this is where things get really weird and really powerful. A qubit can be a 0, it can be a 1, or, and this is the crucial part, it can be both at the same time. This mind-bending ability comes from two key quantum principles. First up, we have superposition. That's the fancy name for this strange ability of a qubit to exist in multiple states at once. Because it can be both a 0 and a 1, just a few qubits can explore a massive number of possibilities all at the same time. This creates a computational space that just grows exponentially. It's not just adding power, it's multiplying it over and over again. And the second principle is called entanglement. This is the one that even Einstein found bizarre. He called it spooky action at a distance. Basically, you can link two qubits together in this really profound way. They become entangled. And once they are, the state of one instantly affects the other, no matter how far apart they are. We're talking miles, even light years. It's this spooky connection that lets them work in perfect, complex harmony. So when you put these two crazy principles together, superposition and entanglement, you're not just building a faster computer, you're trying to reach a landmark moment in the history of computing. It's a milestone with a pretty bold name, quantum supremacy. And quantum supremacy isn't just a cool marketing term. It's the official finish line. It's the point where a quantum computer proves definitively that it can solve a problem that is practically impossible for any classical supercomputer. We're not talking about being a bit faster here. We're talking about playing a completely different sport in a completely different league. Now, Google actually first made this claim way back in 2019 with a 50-qubit chip. But, there was some debate. Competitors like IBM argue that actually a classical computer could crunch that same problem. It would just take a few days. But this time, with Willow, the leap is just so massive, so astronomical, that the debate is pretty much over. This claim is undeniable. And this is exactly why. See, going from 50 qubits to 105 qubits doesn't just, double the power. This is the key part. Because of superposition, every single qubit you add doubles the machine's total processing power. So that jump makes Willow not just twice as good, but orders and orders of magnitude more powerful. The difference is, frankly, Astronomical.
But look, raw speed is only half the story. One of the biggest challenges in quantum computing is that these quantum states are incredibly fragile. I mean, the slightest little vibration or temperature change can mess up the whole calculation. It's like trying to build a perfect house of cards during an earthquake. But what makes Willow a true breakthrough is its advanced error correction. It's like a sophisticated shock absorber, making the whole system way more stable and reliable. And that is a giant leap toward making these things actually practical.
So, okay, a faster, more reliable quantum computer is finally here. What does that actually mean for us, for the future? Well, this isn't just some abstract achievement for a lab somewhere. It really does signal the beginning of a whole new era in what we can achieve with computers.
So let's just boil this all down to the key takeaways. First, we have speed like we've never seen before, solving that 10 septillion year problem in minutes. Second, it has cemented the idea of quantum supremacy as a fact, not just a theory. And third, and this might be the most important part, its advanced error correction means these machines are getting stable enough for the real world. They're becoming reliable tools. And that really just leaves us with one final, kind of awe-inspiring question. Think about it. For all of human history, there have been problems we just filed away as unsolvable. Things like designing brand new medicines from the atom up, creating materials with impossible properties, or maybe even cracking some of the deepest mysteries of the universe. If a problem that was supposed to take longer than the age of the universe is now solvable in an afternoon, what other impossible problems are we about to solve next?